I see Amy, Sasha. I know Sasha. I've talked to her before. Amy, you're somebody new. Maybe you can just tell me a little bit about yourself and what you're thinking about for education.
Can you hear me?
Yeah, go ahead.
Okay, so I've been a science teacher for about 25 years. Just recently completed my Doctor of Education degree, and my dissertation topic was on cognitive science and the science of learning and how learning happens in the human brain. And so, from that perspective of how learning happens, has led me to start looking into what are the teaching or instructional methods that best align with cognitive science. Of course, as a science teacher for the past 20 years, we have had inquiry drilled into us. And so it's never really felt right to me. And then I started reading about cognitive science and seeing the cautions of using inquiry as a teaching strategy. So here I am to learn more about direct instruction and explicit instruction, because that seems to be the direction that cognitive science says is the way to go.
Yeah, there's a confusion between experimenting in science and discovery learning.
Yes.
And I think we get confused. Like the kids are going to learn everything. I mean, great scientists learn these things, and kids are not going to do it by themselves. I mean, you
No,
can have a very focused, drop things and measure it and come up with acceleration or something. But anyway, yeah. Do you remember when the next generation science standards came out? Okay, I had a big go around. What state are you in?
I'm in Tennessee.
Oh, okay. Oh, I've worked at the Tennessee Principals Conference several
Oh,
times. I think it was at the
yeah.
elementary one, and I've worked with some schools there. Anyway, so there was that big, when it first came out, I was with the state of California, and the way it's laid out, there's a column in the middle and then there's things on the sides. And I said, the things on the side are the engineering applications, the real life. The one in the front, they finally admitted you have to teach that. It's not inquired, you have to teach it.
Yeah.
So I
Yeah.
said,
Another big change that's happened is they've completely eliminated scientific method and replaced it with engineering design, and they're not the same thing. So, teaching engineering design is does not replace teaching scientific method.
well, if you look at the explicit direct instruction book, you've probably seen that. And my wife, Dr. Sylvia Barr, she was a high school physics and chemistry teacher, and she was a scientist in industry. And my actual degree is engineering, is mechanical engineering. I'm just going to mention the student engagement. I could do a whole training just on this. I'll get to it in a minute, but very quickly, we want kids to be more engaged, and we can make them engaged, okay? And so these are some strategies we use. We have students pronounce new words. We teach them how to say words: mitosis, osmosis, interphase, prophase, metaphase, anaphase. Students need to know how to say big words. All right, we do a lot of tract reading or choral reading. What grade levels do you work with?
I'm eighth grade. I'm middle school.
Okay, middle school. That's mitosis, I think, is a middle school. And density, I think
Yeah.
we've got those lessons. Yeah. Okay, so kids need to read the academic content. Common Core actually said that students learn from the content they're being taught from. These are engagement norms. This is what most of our training, our basic training focuses on. Basically, is getting teachers to be more interactive. And like I just said, you can get these off of our Edusary website. You can download them, or I think even DataWorks has got them also. So pronouncing words, tract reading, we practice reading the content, that we're being taught from. Gestures to remember things, okay? Pair shares, because I want the students to talk and interact, left tell right, right tell left, and we always cue for complete sentences. The steps in the process of mitosis are, how can you remember them, or the step in this slide is, and how do you know? So usually we have complete sentences with academic vocabulary. Attention signal when you pair share a lot to get kids back. And are you using whiteboards? Yeah, the whiteboards, they're game changers too, because all of a sudden you see all the answers. You can see errors, and you got that percentage. Our goal is minimum 80%, reteach to 80%. You can see it right away. And it forces everyone to participate, right? They're like, yeah, I'm waiting for two people. You have to get your board up. Yes, you in the back. You have to show your board. So, discipline is something we kind of address on the side. It's not the main thing, but a lot of these help with discipline. All right, so I'm just going to show you one right here. We've done a lot of classroom observations, and this was one I did a couple years ago. We saw 45 teachers. So you probably recognize these lesson components: learning objective, activate, prior knowledge, concept, skill. Okay, and then these are what I call engagement and checking for understanding, higher order questions, pair share, whiteboards, sentence frames, non-volunteers. So out of 45 teachers, and it was actually in 2 schools, learning objective was maybe 1 teacher. Activate prior knowledge, a couple of teachers. Concept development, it looks like it's way out here, but that's only like 25%. 100% is way over here. All right. And then we get down here, higher order questions, only 1 or 2 teachers, pair shares, sentence frames, a couple. So almost no practices were going on. This is 45 teachers. I'm with the superintendent and assistant superintendent. And finally, by the end, my tally of the 2 schools, in one school, almost 50% were working by themselves, and 75% in the other school were working by themselves. And this kind of launched the reform at this district. This is in Texas where I'm working now. And this is where inquiry can be in the extreme as the kids are working by themselves too much. Okay, the other half we see, it's not on this one, is the teacher does all the talking like lecture style and no interaction with the students. So it's kind of the two extremes. Anyway, this is what we found here. So the reform was for this school, we need to work on lesson components. We're actually teaching components, and we need a lot more interaction and less of the students just working by themselves. All right, so let's see what we got here. Have you observed other classrooms at your school?
No, I don't generally get out into other teachers' classrooms very often,
Okay, yeah.
unfortunately.
Well, this is a funny thing. I go to the school and the teacher said, "What do you know? I've been working here for 20 years." I said, "I just saw everyone in the school today." I'll tell you the problem as a teacher. You see yourself teach for 20 years and you don't get any feedback. I go to school and said, "We're going to do teacher walkarounds. We're going to get groups of teachers walk around and discuss what we see." All right. So I'm going to skip down to a couple of things. The history of DataWorks. So we looked at student work. We've been in a lot of classrooms. We eventually put together EDI, but I want to get more to actually practices right here. So let's look at effective instruction. Evidence-based plan for creating and delivering well-designed, well-taught lessons. So if you're taking notes, the 2 things is design and delivery. Design is objective, activate, prior knowledge, concept. Delivery is what? Student engagement, pair share, answer and complete sentences, explain your thinking. So there's really 2 of them. You need both of them at the same time. So what would be effective instruction? Produce at least 80% whole class initial teaching. And I've been in classes where the success rate is very, very low. I said, that is not effective enough what you're doing. Now, here's something you can put this down as a note. You reteach to 80% and then corrective feedback to the individual students. I see, can you go back and check paragraph 1? Can you check your numbers? Can you look back on the diagram? Can you explain to me now? So don't reteach to 100%. You're reteaching for fewer and fewer kids, for 3 kids, then 2 kids, and you're just kind of getting repetitive. So we just give corrective feedback. But generally, the idea is you try to end up with 100%. So if the whiteboards go up and you call a couple correct ones, you've got 2 or 3 incorrect ones, then you cue and prompt them until everybody has the correct answer at the end. Okay, so effective instruction works with all grade levels. It really doesn't matter whether it's science, social studies, whatever it is. It should work with whatever we work on, and all age levels also. Now, here's another one. Here, I'm going to ask you to Coral read, and Derek, you can read it with me because this is one of our strategies. So, class, I know you don't need this as an adult, but we're going to try it right now. Amy, can you unmute so we can practice this how we would do it? Okay, but let's read the third bullet. Ready, go. Students
Students
learn
learn
concepts
concepts
even if
even
there are
if
some
there are some
subskill errors
sub-skill errors
100%.
100%.
Okay, so let's give you an example. You do density, it's mass over volume, okay? And by the way, that's not what density is. That's the formula for calculating density. Density is the amount of material together. And I see teachers do that formula over and over. I said, no, no, it's how closely packed the material is. Don't just memorize the formula. All right, but anyway, everybody should know how to solve it. And even if they make an arithmetic error, that's a subskill error. But they should all know density, what it means, and how to calculate it, okay? 100% know what it is, how to calculate it. They may make mistakes in the arithmetic or something else. So don't let subskills hold you back. Poor reading, math facts, and stuff like that. We want everyone to come out learning new concepts. Okay, effective instruction, and I like to call it EDI, effective instruction. Okay, I'll let you read the colored ones. Derek, you in there also? You're going to read the blues and the
Yes.
greens. Okay, ready, go. Effective instruction increases. Your turn.
Motivation.
Improves attendance. Encourages more students to
Turn in.
turn in homework. And reduces discipline problems. Okay, this is a big one. Motivation. Amy, just write these three down because these are the three things for motivation. The first one is non-volunteers. When you start having your sticks and you say, everybody be ready, your name can be called anytime. Okay. Oh, and a big hint, don't put the sticks to the side, put them back in the jar so you pull two in a row sometimes. You just called me. Well, you have to be ready all the time. So this is a game changer. Everybody says, wow, I got to pay attention. Okay, the second one is lesson importance. Why are we learning this? This is easy to do in science. Mitosis, this is how our body repairs, an injury or something, right? I know there's stuff in rocketry, or this is how we go to the moon, or this is formulas we use for this, or gravity is used for this. And so the lesson should have an importance. In EDI, we have an official importance screen, and we teach importance. Okay, the third one is, quote, I can do it. The self-motivation. The kids at the end say, wow, I can do this. And I've had kids very excited, oh, I can do it, I can do it. Kids love to show their whiteboards, when they've got the right answers and everything. Wait, give me 1 second because I've got one more person joining. Sasha, oh, there you go. Sasha, is your mic on?
I'll turn it off.
You can leave it on because we're doing choral readings. All right, so we had the three for motivation. Improves attendance. We did a big government contract in Australia. Attendance was a problem. I think if for a classroom, it doesn't have to be entertaining like comedy, but it has to be engaging. If it's engaging and it's not brain busters, the students will show up. The students will show up. Now, turn in homework. We were in Burbank, California, and we taught a demo lesson. The teacher came back and says, I can't believe it. After the DataWorks demo lesson, kids turned in homework, and they'd never turned in homework before. And Sylvia, from DataWorks looked right up and said, that's because they knew how to do it. So this is the secret for homework. Students already know how to do it. It's not to learn on your own. Don't have the kids go home and learn some science thing on their own, and you're going to figure it out or develop it on your own. The research actually is homework is a cognitive practice for repetitions for automaticity, but not the initial learning. That is the research on homework. Okay. Reduces discipline problems. In the typical engagement, everybody show your whiteboard, everybody turn and talk. I'm calling on you. I expect you to respond. And so a lot of this kind of suppresses or preempts discipline. It really works very well for that. Okay, so I have a checking for understanding question coming up, but we talked about effective instruction has to generate 80% success level, a minimum level. If you're not getting that, you need to rethink your instructional practices. It works with all grade levels and disciplines. We've used this in, Derek, you remember that researcher from the college professor? He was actually using it in medicine. I think medicine was where he was using it. He says, you want to do inquiry teaching in medicine. I'm going to show you how to do the surgery, and you're going to do it exactly how we're going to do it. Okay, and then everybody learns the concepts because even if they make sub-skill errors, and then we improve motivation, attendance, and homework. So here's my question right here. So one of my strategies is to have the students read the questions because look at my academic language in here. Effective instruction. That's here because effective instruction is the name of the slide, and I want you to use those words. So choral reading is one of our strategies. So class, let's read the question. Ready, go. What insight do you have about effective instruction and why? Okay, now when you answer, I've got the sentence frame for you, and I'm going to read it for you. My insight about effective instruction is blank because blank. That's the way you're going to respond. So these are my tips to myself, whiteboard, pair share. So let's do this right now. Everybody get a piece of paper. We don't have a whiteboard, but just write down 1 or 2 words of something you learned off of this page. We don't have actual whiteboards. In the classroom we would, but just a piece of paper works on these. Okay, now we're going to simulate the pair share. I'm not going to do it every time, but let's do it this time. So I want you to pretend you have a partner sitting next to you. You're going to turn 90 degrees and you're going to say, my insight about effective instruction is, and you're going to read your answer, and then you're going to justify why you picked it just on your own. So let's just do a simulated pair share right now. Everybody, you should be turning 90 degrees. Okay, my insight about effective instruction is teach corrective feedback to 100%.
My insight about effective instruction is that they turn in homework because they already know how to do the problems.
All right, I think we're ready now. So, Janet, let's see the whiteboards. Up, 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 up. Okay, push yours in a little bit so I can read them. Okay, so I'm going to start with Amy. Can you read your answer? Don't forget your sentence frame, my insight.
My insight about effective instruction is students should learn concepts at 100% because all students need to know what's being taught.
They need to know the big ideas. And if you've ever looked at state testing, there's a lot of analysis, conceptual questions versus skill-based questions. And a lot of science questions are kind of conceptual questions. Okay, Sasha, can you read me your answer? My insight?
My insight about effective instruction that it is usable for all grades because it is based in how we all learn.
Yeah, I'm going to do a little brain research in a minute. Okay, I just want you to know that this is the way we do the training because I want you to see how it works in the classroom. The first time I did one of these with whiteboards, it was a game changer. I used to be the droning presenter, like typical PowerPoint read, nobody did anything. And I said, why aren't I using my own strategies? Let's use whiteboards, let's answer incomplete sentences, let's do it. It's very effective. All right. I'm going to skip the instructional leadership. If we had more principles, I would work on instructional leadership. I'm just going to give you one hint. Instructional leaders must work on the instructional program. They're usually plant managers sitting in the back, the buses, the scheduling, the buildings, and they don't really work on instruction. And I'm just going to tell you, Amy, our schools is the principal should be in the classroom part of every day.
Hmm.
And I usually ask, how many times you've been seen? Our real strategy is every teacher observed once a week. And teachers observing each other also. Okay. I'll show you the brain research on this in a second, but you do need effective feedback to do things. And that the principal's part of that job is to be out there and providing the feedback, plus with coaches and stuff. And they're very simple feedbacks. Can you have the kids pair share? Can you have them answer in a complete sentence? I say 99% of the coaching is this one page right here. And by the time we're coaching, everybody knows what this is. I'm not just giving an off the wall, what I call random coaching. It's all systemic coaching to predefined criteria. And this is usually the main one we do. Anyway, I'll just say that's one thing that principals should be doing. They should be in the classroom, okay, because we're working on the instructional program. Let's go to brain research. Memory retention is ability to store information. We have the teacher talking out here, and we're trying to get to long-term memory. So we've basically got these three different memory systems. The first one is sensory memory. Can we all say that? Sensory
Sensory
memory.
memory.
Okay, this is the problem right now. This is me talking and you are hearing and seeing it, but it's not going to long-term memory. It's just kind of in one ear and out the other. And this is the problem with typical lecturing. It does not get to anywhere near long-term memory. Within a few seconds, it's gone. Okay. Now, the next one is your working memory. That's your consciousness. And I think you've probably all heard the research 3 to 7 items. Our working memory is very small. And what we're doing is we swap in and out with long term memory. Now, let me tell you the implication for the teacher. Amy, you know all the science content yourself already. You know the steps of mitosis, D, M over V. You know all of it. You're actually working from long term memory, but the kids don't have any of it. They're hearing it for the first time. It really has to be an overteach, an overkill, more repetition, more explaining. And I think teachers are fooled. And Derek, I've seen it in math teachers is probably the worst. Math teachers are so confident in math, they think everybody should know it the way they do it. So it shows up in math, but it's in science in every place. So remember, the kids are only working right here. Okay. All right. Then the last one is if we get to long-term memory. Let's read the characteristics. Ready to go. Unlimited
Limited
capacity and
capacity
duration.
duration.
That's multiplication facts when you've memorized them, addition facts, your birth dates, everything you've got is in long-term memory, and what you're doing is retrieving it. Now, if I asked you right now, what's 6 times 8, all of you would say 48. Some of your students do not know that. Now look at this brain model. Why can they not tell you 48? It's not in long-term memory to be retrieved. No amount of cheering, punishment, nothing will work if they don't know it, it's not there. So part of our job is to what? Is to get it in there. All right, so we've got higher order questions is one strategy that helps multimedia experiences, but higher order questions or higher order thinking is one. So I've given up on Bloom's and DOK. It's just we used to classify it just defend your answer, explain your answer. Anything where you're not reading back directly from the text is higher order thinking. You're having to create your own answer. So here are some ways we can do it that are actually part of EDI as part of our questioning. Remember my question a minute ago, I said explain why, justify your answer. So let's read how we can do this. Read the first bullet, everybody. Ready to go. Justify your answer.
your answer.
Okay, you wrote the density was 12. Explain how you got it. Okay, and explain the units. How did you get it? Okay, let's read the next two. Ready to go. Interpret your answer. What does it
What
mean?
does it mean?
Okay, so a lot of times when you're comparing, remember we're trying to is it gold or not? We're using the density. So you've got the density of the unknown and the known. They're the same. So what does that mean? Not just it's the same. They're the same. No, what does that number mean? What's the impact of that? Okay, let's read the next one. How do you know? This is just another variation of justify your answer. Okay, let's read the next one. Explain your thinking. I use this a lot for incorrect answers. I see a different answer on your whiteboard. I see 12. I see another one has 24. And maybe can you explain your answer how you got that? Okay. And the last one, textual evidence. Okay. Science, some of science is text-based. It's just it's declarative knowledge, right? Then there's other kind of procedural, like density is kind of a procedural knowledge. You're actually calculating it. And like the animal kingdoms is declarative knowledge. So you might be asking somebody to explain something. Oh, here's a new rule for science. They need to be working out of text, maybe 20% of the lesson. We're reading text, analyzing text. So you might be able to explain something. Kids, now read the next paragraph and be ready to report out to me what it is telling us about something. Because I remember the Common Core said use the literacy approach. And they said declarative knowledge, expository text is done in science and history. And so part of the lesson is reading. It shouldn't just be a lecture the whole time. All right, so the idea is what? Which ones of these can use? You know we're going to have a checking for understanding question. Okay, let's read together. Ready to go? Which higher order thinking will you use in your classroom? Okay, when you answer, let's read together. We'll say blank, blank. Ready to go. The higher order thinking I will use is blank because blank. Okay, go ahead now. Write on your whiteboard. Which ones of these can you use? Okay, I think you got your answer there. Let's see the whiteboards. Up, up, up. 1, 2, 3, chin it. Sasha, can you read your answer to the class? Go ahead.
Sure. The higher order thinking that I will and do use are all of these because I want to know how and what my students have observed and have integrated.
Okay, good. We have a phrase for this in Dow. I call them process questions. How did you do it? And Amy, when you solve something yourself, your question is how did I solve it? Not what is the answer. 12. No, how did I get that density? How did I calculate it and explain it? Especially if you had to take it out of a word problem, for example, something like that. Okay, Amy, can you read me yours?
Yes, the higher order thinking I will use is explain your thinking because it will help me identify gaps in knowledge and misconceptions.
Yeah, that's another good one because misperceptions, we can get those and then it allows you to re-cue. And let me tell you, misperceptions, sometimes they don't understand a vocabulary word and other times they don't understand the process. All right, so let's go on to the next one. The brain takes a lot of information. The brain cannot decide what to remember, the teacher talking or the conversation in the classroom. The brain doesn't know what to remember, but the brain will remember what's repeated and what's rehearsed. And this is a little research here, 24 exposures to get it. Okay, now that doesn't mean we chant. Now some stuff we do just plain chant. We do it. That's a cognitive strategy to remember. But like density problems, we solve 2 or 3 density problems. We pair share with a partner. So, well, let's just look right here. How can we get more interaction? Now, let's read the first one. Ready to go? Choral reading. So when we read, mitosis is the process of cellular reproduction. And we're all going to read together. And sometimes for tricky stuff, pre-read first so that students don't mispronounce. For young students, we pre-read everything. But there's a trade-off as you get older. But a lot of science, the words are so big and so new, you probably need to pre-read. Now, that choral reading can count twice. How do we get 2 more interactions? I read it and you read it. Okay, let's read the next one. Pair shares. Okay, that can count twice. A tell B, B tell A. And it's also listening and speaking. Okay, let's read the next one. Answering questions. Okay, generally we call about 3 students. So when you call 3 students, you're hearing the answer maybe in different words from 3 students. And usually as a teacher, you kind of paraphrase, elaborate, maybe clean it up if it's not perfect. So the answering questions could add 6 more repetitions. Okay, the whiteboards, just the physically writing it on your whiteboard. Let me ask you, did some of you write your complete sentences on your whiteboards?
Mm-hmm.
Okay, now I want you to imagine in science, you're actually writing those words out. You're not just writing the 1 word or 2 word answer. In EDI, I don't do that every time. It takes a long time to write out the whole sentences, so make a judgment call. Sometimes you just say, write the 1 or 2 words, but you have to answer with a complete sentence. But do have them write once in a while, because there are words like mitosis, they're never going to write that word in their entire lives. I mean, very seldom is that going to show up. It may show up again. This may be one of the few times they're actually going to write the word out, and I expect it to be spelled correctly. It's right there on the board. Maybe we need to spell it together to practice first. Okay, so work on spelling for the content words you're teaching. I mean, kids have a lot of spelling errors. Okay, so whiteboards. And the last one, of course, is solving problems. Besides writing the answer on your whiteboard, maybe you're solving step by step, you're doing it. Usually, if we were doing, I'm just thinking mitosis because we talked about it so much. So draw telophase on your whiteboard, sketch one out, and show me what it looks like as they're starting to pull apart. Okay. All right, so this could be a good one. The whiteboards don't have to be just be words. They could be a drawing. You can be marking something on a diagram. You can have 10 cells, circle the correct cell. Are you using the whiteboards? We use these sheet protectors. Have you ever used those? Okay, put the mitosis handout inside this and have
Yes.
the kids
Yeah.
circle and hold up. That makes it really fast,
Yeah.
really fast. If you're going to plot something, put the grid in here. Don't have the kid draw the grid. Then they can erase it and do another problem, erase it and do another problem. However, don't let them do everything in here where they end up with no paper notes. So generally I say, kids, the one I work, I want you to write down, but the ones you work, we're just going to hold them up and erase. Don't let the kids take their notes on their whiteboard. I've seen that because they're going to be erased. All right, so I think we've got this. How will you provide interactions in the classroom? Quickly, 1 or 2 words on your whiteboard, and then be ready to report out, I will provide interactions by blank because blank. All right, are you ready? In the classroom, we would pair share, and I want you to use your sentence frame. And I'm going to tell you, in reality, you have to cue the kids for the sentence frame. They want to just give you the 1 word answer? No, I want you to say the perimeter of the polygon is the density of the rock or of the unknown or of the metal or of iron or whatever you're doing. So a lot of times you have to cue kids. Once they kind of get the idea and they're kind of what I call trained, then it's a lot easier. Okay, boards up. Okay, so I'm going to call Derek this time. You have an answer. Can you read me your answer? Don't forget.
Sure, I'll provide interaction pair shares because it creates an audible and verbal repetition for both people involved.
That's multimodality. Okay, Amy, can you read me your answer? I will provide.
I will provide interactions by pair shares, whiteboards, and choral readings because it requires all students to participate and gives immediate feedback to the teacher.
Yeah, everybody has to do it. Everybody has to do it. Okay, let's go on. Amy, this is for you to tell the principal, okay? And Sasha, I know you've done training, but let's look at this. This is a famous study, Joyce and Showers. This is why it's so hard to implement, why school reform is so hard. This is people transferring a new skill as a result of professional development. If you take a look up here, the implementation of a training like today is 5%. It's unbelievably low. Most professional development does not work. You have the training on Friday, by Monday you've already forgotten it. But now, seeing a demonstration, haven't we been doing a demonstration right now? I mean, you're way beyond. You've been practicing. You've been seeing it, right? You've been seeing it, and I've made you do it. So we're beyond the 5% here. Okay, but the 90%, let's read the blue part. Ready? In situation coaching. Remember I told you a few minutes, the principal should be there, the coach should be there. I know, Amy, you could coach your teachers right now. You could say, wait, you should do a pair share. It's so easy to see. It's not easy when you're in front of the classroom. You don't realize you forgot, but you could coach almost immediately. All right, now, here's the thing for teachers, and Sasha, I think I may have explained this to you once before. This whole brain strategy still works for teachers. We have that very small working memory. So what the human brain does, it develops habits. Your car drives you to school. You don't even have to think about it, your habit. You teach by habits. You don't think about what you're doing. Whatever you're doing, you're on automaticity. The problem is we're trying to rewire your brain. You're going to use pair shares now. You fall back into your old habits and don't even realize it. Okay, so this is why you need the coaching. You're trying to make the new habits. 24 repetitions, I said, for the students. We actually need the repetitions for the teachers. They need to do it. And Derek, I just got back from Texas. I've taught 24 days of demo lessons over there. I mean, just everything from K to 12th grade.
Yeah.
And when the teachers teach after me, I'm seeing their pair share, remember to pair share. And then it kind of clicks after you coach a little bit. Okay.
Yeah.
All right. So I'll ask this to you, Sasha. How will you provide in situational coaching?
I will provide in situational coaching by working with the coaches on a monthly basis and creating authentic learning experiences for the teachers they coach, because I know that without coaching, they will not be able to generalize new skills to the classroom.
Yeah. See what happens? We're at the knowledge level. Everybody knows pair share, complete sentences. Oh yeah, I remember those. Those are on the poster, but we're not actually doing it. We need to go from awareness to automaticity where we do it without thinking about it. Let's go on. This is everything on one page. So remember we said EDI is design and delivery. So here's the design part over here. Let's see if I can blow it up. Learning objective really should come from the standards. It should be from your grade level standard. And I think if you've looked at the standards, they're very long. You usually have to chunk them. They've got 2 or 3 things in the sentence, so just do the part you're doing. And one thing, Amy, I'll just tell you, you should have a Bloom's type of verb. We will identify, describe, analyze. Don't have we will do math. We will talk about this. We will learn about. And those skills are usually in the standards. They usually have it in the standards. So try to use those words and try to have the kids work with those words, determine, analyze, evaluate. They're good vocabulary words. Okay. Connect to prior knowledge. Go over something to get the kids ready to start for today. It can be a sub-skill, or we can look over the periodic table because we're going to do something new with the atoms today or the elements. But this is the main thing we need to look at for concept development. Let's all read the red part together. Ready, go? Written definition. So someplace you need to say, mitosis is the process of cellular division. It needs to be written. I see teachers just try to ad lib. They kind of tell about it. They don't really have an official written definition up there to read. Once you had definitions, you need to have what I call labeled examples. So I've used mitosis several times. There are 7 steps in mitosis. Here's the name of them. Here's a little graphic organizer. Here's the name. Here's the description. And here's a picture of what it looks like. Okay. Let's see if I've got the mitosis lesson. I've talked about it so much. Have you heard of Edusary? Those are our online lessons. Let's see what we've got. So we can just talk about the conceptual part of this for a minute. Describe the process of mitosis. I think process probably came out of the standards that uses that word process. Okay, this is our connect to prior knowledge. We already know a few things, chromosomes, cells, and we can label a few things. All right, then basically here's mitosis, process of cellular division, 2 daughter cells. So this is our concept right here. These are what I call our labeled examples. We have a word, we have a visual, and then we have a description right here. And then I want you to also think about the vocabulary, interphrase, preparing, mitosis, duplicates, chromosomes, organelles. Do you see all the vocabularies in here? It's not just science vocabulary, there's other words in here, preparing, duplicates, process. Do you know what I mean? So part of our thing is to teach, this is just a general rule, you need to teach general academic vocabulary, determine, correspond, separate, evaluate. So students get mixed up on that in testing. And see, usually what the book does, the book defines all the science words, but then DataWorks added these other words, duplicates, and some of these other words in here. Okay, then we always have a checking for understanding question. And the checking for understanding question is an application question. It's not a repeat back of the definition. We actually chunk the lesson so you're not trying to teach the whole thing at once. It's just too much to look at. Then we have a checking for understanding for each one. And again, and this is the whiteboard. You can see this. Let's read. Which illustration shows prophase? Okay, write on your whiteboards, A, B, or C. Blank shows prophase because this is the phase where blank. Okay, and I think it's the chromosomes start to become visible. All they have to write is C, but they need to respond with this whole sentence right here. Okay, so I think you can see the structure, what I was just talking about a minute ago for learning objective, definitions and examples. Science is usually a graphic organizer quite often. You've taught density, haven't you? Okay, D equals M over V. But the standards say you need to solve for all three variables, mass over volume. Given a density and a mass, what is the volume? Given something, something. So that's really written in the standard someplace. And you have to model those as a teacher, right? Because just because you did one of them, you can't have the kids do the other one, where they have to come up with the other solving. And you can either use algebra to redo it or just give them the three formulas. You don't want to get bogged down in regrouping the equation. Okay, let's look at the next one. Concept is written definitions and labeled examples. The next two, skill development and guided practice. The skill development is the teacher works a problem. If we've got these cells, I'm going to identify the first one myself. Now, kids, let's look at the second one. You're going to identify the second one. Write on your whiteboard A, B, C, or D, whatever the second one is. Now, your question is not what is the answer that I did, is how did I come up with the answer? How did I come up with the answer? So you have to model your thinking. And this should be a process question. Process means the process of how I got the answer, not what is the answer. Oh, that's telophase. What did I do? It's telophase. No, how did I determine it's telophase? And you really have to expose your thinking. Teachers just say, oh, look, it's telophase. Yep, that's it. They didn't look at the diagram, look at the cell shape, compare to the drawing. So you really have to do that as an overkill. Okay, teacher and then students. Relevance, we talked about this in motivation. Teach kids why it's important. And quickly, if you're taking notes, relevance, personal, academic, and real life. There's three reasons. It's personal to you. It's going to be on the test. You need it for next year. And scientists need this. People going to the moon need to know this. Doctors need to know this. Hospitals need to know. So those are the three choices: personal, academic, and real life. And I give the kids a choice and they have to defend which one they picked. Why do you think this is important? That makes it a higher order question. It's not a recall. Give me one of the reasons I gave. It's pick one and tell me why you selected. You get amazing things. I want to be a doctor when I grow up. I want to get a good job. I want to be able to get into college biology. So make kids think about it a little bit. Okay, the closure. Initially, I used to give a problem, kids. Let's solve this one and see if we've got it. No pair shares. Let me just see what we got, hold up and see where we are. And the rule is if the kids can't do it, we don't give the homework or we modify the homework. Don't have the kids go home and work on stuff they can't do. Okay. But I have a new closure now. You can write this down. Summary closure. What did you learn today about blank? And then they have to do it. So let me just go back into mitosis one. I'm using my little table of contents here. I'm scrolling all the way down to closure. So closure could be just solve one more problem right here. Okay, right on your whiteboards. And then, compare what we're seeing. All right. I usually have a conceptual type of question. And then this is the one I'm using now, is just what did you learn today about describing the process of mitosis? And we have a word bank. Students, let's read our word bank. Cell cycle, division, increase, daughter cells, identical chromosomes. And I want you to write a couple of sentences and use these words. Now you can use other words we talked about, but here's some words we're going to use. This is actually not a quiz. You're not trying to measure if the kids learned. It's actually a cognitive strategy. I want you to think about what you learned, and you're going to pair share and tell your partner what you learned. Have your partner tell you what you learned, and I'm going to call 3 or 4 people to report out what they learned. And Derek, I usually run out the clock on this. I start with about 4 or 5 minutes left. And if I still got another couple of minutes, I'm going to call another person. I'm going to call another one. I'm going to call another one.
Yeah.
Any volunteers want to raise their hand? And so I kind of run out the clock. And it's a good cognitive strategy to have the kids think about it. And then it's not really a test. It's really a cognitive strategy. It's better than an exit ticket. All right, now I'm going to jump right up to this. Let's go to these because, Amy, these are directly usable in the classroom. So let's start with the pronounce with me. Point to a word and have the kids pronounce it. It's basically that simple. This word is engagement. Students, let's all say it. Engagement. Let's say it. Say engagement to your partner twice. Engagement, engagement. Okay. This is a good one you can use. Backward syllabication. I can't read this word, but I'm going to do it backwards, so say after me. Nucleic. Your turn?
Nucleic.
Ribonucleic.
Ribonucleic.
Nucleic. Okay. Oxyribonucleic. Oxyribonucleic. Now we're going to have the last part, D. Deoxyribonucleic. Let's all say it. Deoxyribonucleic. Now let's just say it as one word. Ready, go. Deoxyribonucleic. I was almost speechless the first time I did this. I can sight read this word. Amy, let me ask you for the cognates. Doesn't this mean it's from the nucleus? I think it
Sure.
does. Nucleus. Ribo, I think, is proteins, and we're removing the oxygen from protein. Is something. There is a cognate for it. Let's just look at a couple of videos. All right, let's see. Pronounce with me.
You've had in the past. Congress, can we say the word? Congress. Let's read together. Congress creates all the laws for the United States. I want you to highlight, do you have your highlighters? Let's highlight these two words. Congress creates. They put them together, they make them. This word, have you heard of the word represent? The word represents to stand for or in place of. Now that's the word represent. Can you say the word represent? Represent. Now look at the next part. The people in Congress are called representatives. Representatives. Let's say it together. Representatives. Say it to your partner twice. Okay? And we call them representatives, the House of Representatives. And the other one's Senate. Can we say that word? Senate. You know, it looks like you might say Senate because of the silent E, but in this case it's like the word it. Can you say Senate? Senate. That's the way it's said. Let's say it one more time. Senate. So let's read the whole thing. Ready to go? Congress is made up.
Okay, you can see I'm integrating the reading, vocabulary development, and everything. So it's kind of classic EDI. All right, let's go down to the next one. All right, the tract reading. Okay, now there's 3 ways to do this. The most supportive, you read the whole thing and the students read it after you. But sometimes you only need to read a couple of difficult words and then read the whole thing because there's a lot of sight words and easy words. If it's something simple, let's just read it together. Choral read. It's more for engagement. And the chunked reading is where you just read a couple of words and then the kids read a couple of words and then a couple of words. Do you have some real struggling students in some of your classrooms? Okay, the chunked reading is what you do it. Can you say it after me? Mitosis is, the process of, just do it like that. And you can even work with non-readers. I've had non-readers. It's surprising. I've had a few, and I do that chunked reading. It's also your differentiation for struggling students, for English learners, for special ed, whatever. Oh, okay. Let's look at plate tectonics. That's a science lesson.
Divergent boundaries. Let's read it. Divergent boundaries. So this is a new word we have, lithosphere. Can you say that? Lithosphere. And the other one's asthenosphere. Listen again. Asthenosphere. Let's say it. Asthenosphere. I think we can read the first couple sentences. Ready to go. The places where plate move apart are called divergent boundaries. When the lithosphere is pulled apart, it breaks along faults that are side by side. As the plates move away from each other, the rock between the faults drops into the asthenosphere. These are the plates up here. Actually, the lithosphere. Can you just write the word rock? Litho is a Greek word for rock or stone. So it's the rock. Sphere means the circle. So it's what? The part around the earth is kind of like rocks or solid. So lithosphere is the part. It's actually the first 60 miles.
I love to use cognate word parts. Word parts. It's easy to learn and you can apply them. And Derek, I just got back from Turkey. And they said, we're looking at the Paleolithic and the Neolithic eras. And I said, wait, I know what that means. It's the rock era. And it's when they first started using tools. And the Neolithic was when they were forming more sophisticated and stuff. And I said, oh, I remember that from this lesson. All right, so have the kids read as much as you can. All right, the gesture. Do you have any English learners in your classrooms? Okay, gestures are used, it's minuscule, it's gigantic. That's a strategy to convey information. You should be using that. But we're also using cognitive strategies to remember something, to remember. So we're doing something to remember, and they're great for cueing kids later on. All right, so I'm just going to play my high school lesson.
Convergent boundaries. Okay, here's a picture of it. Let's read the definition first. A convergent boundary occurs when one plate dies under another. Circle con, the first part of this word con. Con, I know in Spanish means with. Chile con carne means with something. So con means what? They're coming together. So we're going to remember that little prefix. Con is what they're coming together. They come together and one dies under another. So they don't just hit and crunch like a car crash. They actually kind of go like this. So one flows up and the other kind of bends down. Okay, they're great big and they kind of go like this. So let's do this with our hands. Let's pretend we have 2 continents or 2 plates. As they come together, one of them goes down. So bend your hand down a little bit. and then the other one kind of bend up a little bit. Okay, have you got that? Let's do it one more time. Convergent, what are we doing? Coming together, and we're kind of going like this. Just slip over each other. So it's the same thing. Convergent, coming together, divergent, coming apart. So let's read it. Ready, go. Divergent boundary. Let's read the whole thing. A divergent boundary occurs when plates pull away from each other. So then they diverge, they're going apart like this. Okay, show me your hands. What are they doing? It's pretty easy. They're coming apart. So let's get our hands up there. With transvergent, we're going like this. Right, one more time. Convergent, we're coming together. Divergent, we're going apart. And trans is what? We're going like this. Okay.
Anyway, those gestures really work because later when we're doing something, I can do a visual cue. It's great for feedback. All right, so I would like to do one more thing in here, which is the corrective feedback, which is this one right here. We don't want to get stuck. We want to be able to do something when the students don't have an answer. Let's just read the second one right here. Can we read this? I'll come back to you. Okay, this is a great one. It's just not a natural strategy I've seen a lot of places, but this is a good one. Another one, de-escalate to multiple choice. Which of the 7 steps of mitosis is it? Okay, let me rephrase that. Is that interphase or prophase? You see what I mean? I just drop it to 2. What is it? Is it density or is it acceleration? We can use choices, so drop down to choices. Explain your thinking. That's when kids are stuck. You have a wrong answer. This is their last ditch, is if the kids cannot answer, you say, we're going to read the answer together. This is also a discipline thing. When kids don't want to participate, when you come back the second or third time, say, we're just going to read the answer. Okay? Now let's read this one. Everybody go. 2 wrong answers, reteach.
Reteach.
And Shaw said, this is for coaching too. You need to cue the teacher. Reteach. The teachers get frustrated. They keep calling on kids and reteach. Especially the 3rd wrong answer, it's reteach. Okay. Pair share again will work once in a while if the kids are close, or to practice a sentence frame. If there's not enough knowledge in the class, the pair share again won't work. I've got a couple more science ones. Let's just see what we can do here.
So go ahead and figure out the density, please, and put it nice and big on your whiteboard, please. Show me your whiteboards, please. So the last thing that I want you to do is to interpret the answer. I want you to tell me the density of is So what do you have on your whiteboard, honey?
Density equals.
But the density of what? The density of my glasses, the density of the rock, the density of the paper.
The density of the rock.
Okay, very nice. Can you read me your answer? What is the density?
I didn't finish the problem.
Okay, listen carefully and I'm coming to you. What do you have on your whiteboard? Can you say the density of the rock is?
The density of the rock is 2 grams over centimeters cubed.
And how come you got 2 grams per centimeter cubed?
Because 7 goes into 14 2 times.
7 goes into 14 2 times. Very nice. Can you finish this problem for me, please?
Density for the
Rock?
Yeah, for the rock equals 2 grams
Can you say centimeter cubed, please?
centimeter cube.
Yeah, every time you see that little 3, we read it as cube. So go ahead.
That's the problem with pronunciation and reading the symbols. And you have to teach kids how to read the symbols, centimeters cubed, formulas and stuff. So when I say pronouncing, it's not just words, it's symbols and other stuff too. I think I've run out of time. Amy, where's your school again? Tennessee?
Tennessee.
Well, I'll just say I've done a lot of training in Tennessee. So you might think if this could help your school or something, usually what schools like to have, they like to start with that 1-hour webinar of how to use these engagement norms. Not all the brain research and all that. They just said, let's just start with that. If you're doing a longer training, EDI is usually 6 hours, and we can fly somebody out and do the training if you've got a whole day to do it. How many teachers do you have altogether?
We have about 50 teachers.
50?
Mm-hmm.
That's about the limit for one training. Sometimes we'd split it into 2 trainings. 20, a good size is like 25. Mm-hmm. But I mean, I've done 50. I've done a lot bigger than that also. But there is that possibility. A lot of schools do it in the summer during their training before school starts. They bring us out there. And the other thing to think, you might just write this down, is we can do demo lessons also. We're in Australia right now. We've got 2 people in Australia, Larry and Joe. I think they're both doing demo lessons and training. Texas hired us for 20 days of demo lessons.
Wow.
And They love it. One of the big feedbacks from last time was corrective feedback. That's why I'm kind of bringing that up a little bit more now. The corrective feedback was one of the big things they took out of it. Said, John, the way you handled students who didn't want to participate, students who had the wrong answers, it was like EDI level 2. So that was one. Anyway, so think about this. We could do a 1 hour webinar, or we could do short webinars. 1 hour is usually kind of the limit. I've done longer ones. And then we could have somebody come out there during the summer. But if you want to really think about the reform, the best way is to get the demo lessons. And then I teach the lesson, somebody at DataWorks teaches the lesson, and then we go to another class and teach the exact same lesson again. So the teachers don't teach cold, they watch us do it first. And I tell you, I said, don't memorize what I did. I had the kids answering complete sentences every time. I used the whiteboards every time. It's just the strategies. Don't try to memorize the words I said. It's just applying the strategy. And I stand right up there. The DataWorks person stands right up there. If you forget something, we'll cue. If you get completely stuck, we just take over the class and teach a little bit and then blend it back in. So usually we do that. The demo lessons have to be by content areas. How many science teachers have you got there?
8.
8. Okay, so we could do a demo lesson for science, and then we could probably have 8 teachers, or maybe we'd have to split like a couple periods, early period, and a few more come in the afternoon. Maybe we have like 4 teachers. You get 4 subs, and we pull out 4 teachers, and we do a couple of rounds. And then, of course, we like to do the leadership. This is more with the principal. We walk around and look at all the classrooms afterwards. We make 5-minute walkthroughs. And if you really want to do that, the teachers need to participate on that also. I'll tell you something funny. It takes 5 observations to calibrate everybody. Sasha, you've probably seen this too. Everybody's all over the map. That's a learning object. That's activate prior knowledge. No, that's periodic review from yesterday. It takes you a little bit of locking into what you're actually seeing in the classroom. So about 5 rounds is usually what it takes.
I noticed that we're getting toward the end of the hour here. I wanted to make sure there was time for Q&A.
Well, I'll just start with a question. Something you learned or something you want to ask about or something that might change your teaching. So I'll give you like 30 seconds here to think of a couple things, maybe write down 1 or 2 notes. And something you learned or something you might like to talk more about. Amy, can you start something you learned you could apply or a question if you want to add something?
Yeah, one thing that stuck out to me was you talked about 2 components, the design component and the delivery component. And one of the things that I've been reading through your book, and the intentionality in the design of the lesson is something that has really stuck out to me. The identifying the vocabulary, not just the science vocabulary, but other academic vocabulary that the kids need to know. And then really structuring the lesson in a way that it's in those small chunks with the checks for understanding, the interactive nature of it, and just the intentionality of that, the design, and then how that translates into the delivery in the classroom.
Yeah, you notice I'm doing a check and understanding on every slide, basically.
Yes.
And I did middle school algebra one time. The principal said, John, you did 90 interactions in 45 minutes. And even one of their troublemaking kids said, wow, that period went by so fast. And even I said it went by fast because we were doing a lot. Yeah. Okay, so think about that. The lesson design is, can you see it in your book? When you have that EDI knowledge, you kind of see, oh, this is a concept way over here. Oh, this is a skill problem. Okay, Sasha, something you learned or something you're thinking about?
I'm thinking about wanting to look at all of the things on your website and the examples, because that's what gives me a real feel for it, not just, hearing it, seeing it in action, and then also saying, oh, how can I integrate this into the work that I do and share with teachers so that I'm modeling it and also talking about it.
Yeah, my big change was using it during the training.
Yeah.
You can see I make you read. As adults, you can read every slide, but just reading it makes it more engaging for you. Okay, and when you have partners, the pair share makes it really engaging because you're actually discussing with somebody.
Modeling it. Yeah.
You want to add something, Derek? Because I'm going to add one more sentence.
Oh, go ahead.
Okay, this is my insight from today. Because Amy, I know you were a science teacher, and I focused a lot of it on science. But what I realized today was instructional leadership is important even at the teacher level. This idea of feedback, change, how many repetitions, modifying your practices, being aware of your practices. So, Derek, I'm thinking a little more of this leadership stuff. And I think we could even start working on peer coaching. Teachers could do that peer coaching. I've done a little bit of it, but we should formalize it more. All right, I think we're going to sign off. Amy, we can follow up. You're part of a district also, aren't you? A
Yes.
larger district? And
It's a fairly small district.
how many schools have you got?
We have one high school, two middle schools, and I think three elementary schools and a preschool and an alternative school.
Okay. So sometimes when we do elementary training, we just have all the schools come to one place,
Mhm.
you know, unless it just gets too big, then we do it. But usually, I've done training for the whole district at once, but we could separate. Sometimes if you just separate elementary and middle and high school can be together. Like high school and middle school science teachers can be together and math teachers can be together. It doesn't matter. Okay. All right, Derek, I think I'm ready to sign off.
All right, Sasha, Amy, thank you so much for joining us.
All
Okay.
right.
Feel free to reach out with any questions you have. We'll see you guys later on.
All
Okay.
right. Bye-bye.
Yep. Enjoy your week.